Hi there. So I'm doing a little video to show you all these wacky ideas I have, and honestly they look a bit wacky, but they're not, and they don't come from wacky tobacco. No, they're good, well thought out ideas that I've had for the last year now. So be prepared. There are documents all over the table, and it's a wild table full of documents. So basically what I'm going to show you is the three different types of magnetic force levers I've created, where the third type of magnetic force lever becomes perpetual motion. And they're, well, here we go. Here, so the first, here, I'll put this aside here. I want it to, those are magnets, quite strong. So the first one you've already seen here is the magnetic force lever with the heavyweight ball in the secondary wheel with the primary wheel underneath with a larger arc that propels the heavyweight ball inside the top wheel, which allows the top wheel to have more lever. Well, the top wheel is a magnetic force lever. And the second one is, I'll just show half the picture here. Here, this is the magnetic fluctuation ring, which by adding the here, which looks like a fishy little receiver, is the same magnet formation as the magnetic fluctuation ring in opposition, whereas when this ring starts to spin, it will force this little receiver downwards and sideways at the same time. And if this generator here gets any resistance on it and it tries to force back the other way, the force won't try to push the wheel backwards. The return force will go down to the main axis of the magnetic fluctuation ring, which will in effect not allow it to spin backwards. So I've got more research to do on that, and it's quite a complicated one to build because I'm going to need thousands of magnets. That's going to be an expensive one. That will be the second prototype that I'll build. And the third magnetic force lever is this central part here, which I have here in actual physical state, or if you can call it physical state. So basically it's these ends are wheel bearings. They could just be two normal rings with holes in the middle, in the center, so you can get a rod through the middle. All of these magnets here going around. Oh, please don't do that. Oh, there's a magnet hiding behind a piece of paper. So I'll get that off. There. Stay over there. Thank you. Oh gosh, magnets. You've got to be really careful of them. Slightly little fiddle about in the wrong way and they jump all over the place. So, well, basically you've got all of these magnet formations here. So say this is the plus side, this is the minus side. Here you have another plus side, a minus side, a plus side and a minus side. And they are all the same way around, linking the two rings together, which creates a big positive ring and a big negative ring. And through the center I've got a long magnet rod where saying this is the positive side, this will be the positive side of the rod, and the other side, negative side, and the negative side of the rod. You've managed to force that rod through the center, and this rod will be trapped in the center. So I'll finish the configuration here. What I've got to do is get these, each one of these, and bring them down into place. So wait, I'll just put this down here a second to do it with two hands. I think it will be all over the place. Yeah, get this, and that's there. It all fits in nicely. And there. So this is what I got, and it's like it's a magnetic spring. So you see a magnetic spring, doing, doing, and it goes both ways, and the rod is trapped in this spring, in this magnetic suspension. That's more of the word for it, magnetic suspension. And what I figured out to try and do with this magnetic suspension, the rod in the centre could have a bit more powerful magnets so that it has more strength on holdback, but it's totally free in the centre. You can see the rod is just it's not magnetized to the side of the ring. It's just sitting there because it's not. See, it's just floating in there in the middle of the ring. So this, if I get this structure and add here, as I've drawn out here, add weights on the end of the rod, each end, while creating a magnet structure going from the exterior arc of a circle down to the closer center part of the arc of the circle. As this magnetic suspension spins, give it a little push, you can see that it's going to create a force lever effect. The rod is going to be pushed out to that side, the weight is going to counterbalance, and it's going to swing downwards, and as it comes around here, it will have the same effect again. Same drawing here, it'll have the same effect again, and each time it comes round it will push up and counterbalance and come down every time. So I haven't managed to test this in function yet, but and I might have to build this structure differently. It might have to be set in the middle, having so that it will be a positive this side and a positive this side, and the negative will be in the center, so that each time it comes round you just have this magnet, this positive row of magnets here pushing the positive, and it will positively push every way around. And this should create perpetual motion, but it won't be a very fast perpetual motion. As you see here, I've written roughly 240 revolutions per minute, which is a rough estimate. But adding a second magnetic force lever behind should be able to amplify the revolutions per minute by 10 and the force by 2 or plus. There again, I need to build this construction to verify the data on it. Or I could put this first type of magnetic force lever where I'm certain that it will amplify the force, and although this one will not amplify the revolutions per minute, this one will. So yeah, I've got a few details to verify on that. So yeah, this is a magnetic suspension that can be turned into a perpetual motion design, and amplifying the power after that by another magnetic force lever. You can amplify the revolutions per minute and the force it gives out. So hopefully this design here will be my final design, and only thing is I've got to find the cash to build it, which is a real nuisance. So here, what else do I have? I have here I have, this is another type of magnetic suspension. That the center part here is a large 70mm 70 kilogram force magnet. All of these little magnets are linked all the way around all the way around it, and I've already tried this out. If you push the center magnet down, you can have roughly 50 or 60 kilo weight on top of that, and the center magnet will only go down by a centimeter. So it's a very strong suspension, and I've created this suspension, suspension design to be able to go up and down, and left and all the way around horizontally with these what do I call these? Like the hinges here. This is a hinge, and the hinge is attached to the little magnets all the way around, and the magnets will be able to move sideways as well. So it will be like a XYZ suspension, an XYZ suspension. And I've did another thing here. If I can quickly bring it out. Here. So this could be, you could get all of this would fit into this little circular compartment. So we get 1, 2, 3, 4, 5, put them in a different angle as presented here, and you can get a very, 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 very strong suspension that will be very comfortable. Yeah, this is something else I was working on last year. Portable arc generator with perpetual motion powering. I won't go into that. That's quite complicated to go into for a portable arc generator. Here's another plan. This plan is not correct. So if you can see this plan in detail, don't build it. It will freaking blow up. This one wasn't entirely correct after, and this one I believe it is to be correct. And yeah. So this is the other design for the magnetic fluctuation ring. They would have 1, 2, 3, 4 magnetic fluctuation rings with 4 little separate, each having its own motor, and they'll all spin accordingly at the same time, and the large wheel will be powering the large wheel all the way around here. It will be joined to a very large generator. So this one looks pretty cool to build, and yeah, kind of pretty design. And one more design. This one has no certainty of working, but I'll show it to you anyway. So this is basically the same method as this here magnet suspension. See a magnet suspension there, and I was thinking of trying to build an electrical generator out of a grandfather clock style method. So here you would have a long magnet rod arc, and this centerpiece, as you can see, would be attached to the top, and it would swing from left to right, going and hitting the positive and making electrical impulses at each end to create electrical current. And I created this here that would have 2 discs each side with springs to retain it. These would be the bumpers to push it, so when this gets up to here, it would push along, stretch, and this would be the positive coming into the negative here. So this would push along, and the positive would come into the negative here, and it's a complicated world, electricity. But basically, you'd have a pendulum electrical generator. So if you give it a good enough speed, it go and give a certain frequency of electricity. Not sure we'd manage to be able to get 50 hertz out of it without it breaking or something like that. So that's why I'm saying it's a funny idea. Could be tried to build. Could be fun to build. And this was one of my first designs when I was trying to build the Sir Macintosh's perpetual motion wheel. I tried to actually build one. I'll put some photos of the design I built, but I never managed to get it to spin. But this would be that wheel in 0G, because up here I would have all these large magnets here lifting these metal balls on the top of the wheel, lifting the bottom wheel to the same force as the weight of the bottom of the wheel, so it would take all the weight off of the main axis of the bottom wheel, so the bottom wheel would be spinning in 0G. And here you have the magnetic force lever method here that I've got, because you have another wheel here with all the magnets around and the ball in second wheel here amplifying the power. But I like this design, I like this drawing, mainly because it looks like you've got a little Eskimo cat here in the middle. There's an Eskimo cat staring at the ball constantly. Up here it looks like you have a dog, a sitting dog, and I don't know, maybe the sitting dog is looking at that ball there, or a nun lady, or it's kind of a, I don't know, I find that pretty artistic what I did there. It just came out as it did. But anyway, I don't think I'll bother you much longer with all this. If you want to ask questions about anything, about the magnetic suspension, or this type of magnetic suspension, or this type of magnetic force lever, or this type of magnetic fluctuation wheel, or portable arc generator, that would be great. Honestly, that would be something fantastic to have a portable arc generator that would give you 230 volts in your pocket or on your backpack. Anyway, I think I've gone around all that now. There's not much more to say about it. It's quite basic, simple technology that I'm trying to build to make life a bit easier. So yeah, I'll be putting this video on in a bit. It will take a while to upload, and I've got other videos and older videos that I did last year that I'll put on just to commemorate things that I said. It might make me fall back on some interesting ideas or something. Anyway, so that's that. So have a very good year, and have lots of fun, and don't be too ill on the next day. Take care. Peace.